Hello, friends. Welcome back to my channel. So, class busy third semester, and this is this database management system. This is the session number 3, the chapter 1, database architecture. So, last class we had discussed about the concept of a data model. So, data model it consisting of a three different types of a data model: hierarchical model, network model, and the relational model. So, last class already hierarchical model complete ಆಗಿದೆ. Then go to the second model. Network model. So the network model specification of this network model is presented by the Conference on Data System Language in the year of 1969. So which is followed by the second specification is declared in the 1971. In this model, the data are represented by the collection of records and relationship are represented by the link. Each record is a collection of fields which contain only the data value. A link which means that the associations between the two records. So in this, the network model, in the other words, the entities are organized in the graph in which some entities can be accessed through the several ports. So here is the diagrammatic representation of the network data model. So in this, the network data model, here all the data are to be, so point ತೋರಿಸ್ತಾ ಇದೀನಿ ನೋಡಿ, all the data are to be represented by the collection of records and relationship among these data are represented by the link. Each record it is a collection of fields which contains only a data value, and here the link is associations between the two records, so that here the network model entities are organized in a graph in which some entities can be accessed through the several paths. So ಇಲ್ಲಿ ನೋಡಿ diagram ಅಲ್ಲಿ so 4 entities ಕೊಟ್ಟಿದ್ದೀನಿ. The entities either it's a thing or place or anything. You can call it as an entity. Each entity it contains the different number of attributes. Here, a department is one entity. It contains the attributes like department number and department name. Student is also one entity. It contains attributes ID, name, and course. So then one more, the course is also entity. It contains the three different types of attributes: course number, course name, and unit. The professor is also one entity. It contains the two attributes: professor ID, then professor name. ಸೊ ಇಲ್ಲಿರುವಂತ ಎಲ್ಲಾ entities ಒಂದಕ್ಕೂ ಇನ್ನೊಂದಕ್ಕೂ ಲಿಂಕ್ ಮಾಡಿದೀವಿ. So that is each entities it contains the data. All the data are to be communicated via link. The link which means that associations between the two records. Here is advantages and disadvantages of the network model. So it is a simple and easy to implement. It can handle many relationships within an organization, and it is better data independence compared to hierarchical data model. ಈ data model ಅನ್ನ ತುಂಬಾ ಈಸಿಯಾಗಿ ಇಂಪ್ಲಿಮೆಂಟ್ ಮಾಡಬಹುದು, and it is very simple. It can handle the many relationship within the organization. So ಇಲ್ಲಿ ನಾವು ಒಂದು ಟೇಬಲ್ ಅನ್ನ ಹಲವಾರು ಟೇಬಲ್ ಜೊತೆಗೆ ಲಿಂಕ್ ಮಾಡಬಹುದು. So that is it can handle the many relationship within the organization, and it has a better data independency. ಇಲ್ಲಿ ಯಾವುದೇ ಡಾಟಾ ಇನ್ನೊಂದು ಡಾಟಾಗೆ ಡಿಪೆಂಡೆಂಟ್ ಆಗಿಲ್ಲ. ದಟ್ ಮೀನ್ಸ್ ಆನ್ ಹೈರಾರ್ಕಿಕಲ್ ಮಾಡೆಲ್ ತರ ಹೈರಾರ್ಕಿಕಲ್ ಮಾಡೆಲ್ ಅಲ್ಲಿ ಒಂದು ಡಾಟಾಗೂ ಇನ್ನೊಂದು ಡಾಟಾಗೂ ಡಿಪೆಂಡೆನ್ಸಿ ಇದೆ. ಸೊ ಹಾಗಾಗಿ ಇಲ್ಲಿ ಯಾವುದೇ ಡಿಪೆಂಡೆನ್ಸಿ ಇಲ್ಲ. ಸೊ ಡಿಸ್ಅಡ್ವಾಂಟೇಜಸ್. ಸೊ ಮೋರ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಸಿಸ್ಟಮ್ ಆಫ್ ಎ ಡಾಟಾಬೇಸ್ ಸ್ಟ್ರಕ್ಚರ್. ಸೊ ಇಲ್ಲಿ ಲಿಮಿಟೆಡ್ ಅಮೌಂಟ್ ಆಫ್ ಡಾಟಾ ಇದ್ರೆ ನಾವು ಈಸಿಯಾಗಿ ಇಂಪ್ಲಿಮೆಂಟ್ ಮಾಡ್ಬೋದು. ಬಟ್ ಜಾಸ್ತಿ ಡಾಟಾ ಎಲ್ಲ ಇರೋ ಕಾಂಪ್ಲೆಕ್ಸ್ ಡಾಟಾನ ನಾವು ಸ್ಟ್ರಕ್ಚರ್ ಡಿಸೈನ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಸ್ವಲ್ಪ ಕಷ್ಟ ಆಗುತ್ತೆ. ಸೊ ಎರಡನೇದು ಲ್ಯಾಕ್ ಆಫ್ ಸ್ಟ್ರಕ್ಚರಲ್ ಡಿಪೆಂಡೆನ್ಸಿ. ಸಮ್ ಆಫ್ ದಿ ಸಿಚುಯೇಷನ್ಸ್ ನಮಗೆ ಯಾವ್ದಾದ್ರು ಡಾಟಾ ಒಂದಕ್ಕೆ ಡಿಪೆಂಡೆಂಟ್ ಆಗಿರ್ಬೇಕು. ಸೊ ಈ ತರ ಡಿಪೆಂಡೆನ್ಸಿ ಇದರಲ್ಲಿ ಇಲ್ಲ. ಸೊ ದಟ್ ಈಸ್ ಅ ಡಿಸ್ಅಡ್ವಾಂಟೇಜ್. Then go to the one more here, the relational data model. The relational data model was developed by the scientist name, we can call it as EF code, in the year of 1970. Unlike an hierarchical data model and the network data model, here there is no physical link between the each record. So ಒಂದು ಡಾಟಾಗೂ ಇನ್ನೊಂದು ಡಾಟಾಗೂ ಇಲ್ಲಿ ಯಾವುದೇ physical connections ಇಲ್ಲ. All data is maintained in the form of only the table. The table is consisting of the rows and columns. Each row is represented an entity, and each column is represented as an attribute of this entity. In this model, the data is organized in the two-dimensional table so that we can call it as a relations. The tables or relations are related to each other. Rows and columns. Each row represents an entity and a column represents an attribute of the entity because the table is consisting of the rows and columns. Each row is represented as an entity and each column is represented as an the attribute of this entity. So in this example, department, professor, course and student. These are all the entities. So it contains the number of the different types of attributes which are present in this the table. So in this model, data is organized in the two-dimensional tables. That all we can call it as a relation. The relation we can also call as a table. The table or the relations are related to each other. So then the next slide we move on here. Database schema. So what is a database schema? A database schema, it is the logical representation of database which shows how the data is stored locally in the entire database. So in this the entire database, it consisting of the list of attributes and the instructions that are informs in the form of the table. So in this the database schema, it contains the schema objects that may be include either it is table or it is a fields. Fields we can also call it as attributes or a packages or views or relationships or a primary key, foreign key, secondary key, etc. These are all the number of different types of a schema objects which are present in the database schema. So on other words, the schema, it is the logical representation of a data in the database. It is called a database schema. So here is that the one more definition. The database schema, it defines how the data is organized and how the relationship among these are associated. So this diagram which shows that the database schema, that is a student example. So in this student example, ಪಾಯಿಂಟರ್ ತೋರಿಸ್ತಾ ಇದ್ದೀನಿ ನೋಡಿ ಇಲ್ಲಿ. The below layer, it is called as the physical schema. In this the physical schema, it only defines that the actual storage of data and its form of storage, that is like files or indexes or etc. It defines that how the data will be stored in the secondary storage devices. So ಇಲ್ಲಿ ಡಾಟಾ ಹೆಂಗೆ ಸ್ಟೋರ್ ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನ ಮಾತ್ರ representation ಮಾಡುತ್ತೆ in the form of physical schema. That means how the data will be stored in the secondary storage devices. So that we can call it as physical data schema. Then ಇದರ ಮೇಲ್ಗಡೆ ಇಲ್ಲಿ ಲಾಜಿಕಲ್ ಸ್ಕೀಮಾ ಅಂತ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಮಾಡಿದೀವಿ. ವಾಟ್ ಈಸ್ ದ ಲಾಜಿಕಲ್ ಸ್ಕೀಮಾ? In this, the logical schema, it defines a logical constraints that need to be applied on a data stored. That means that what type of a data stored in this database. So physical schema dali how the data will be stored. So here the logical schema dali what type of a data will be stored in this data type. So in this the student databases, it contains student ID, student name, project ID. The student ID in the form of the number or a alphabet, that means for alphanumeric characters ಆದ್ರೂ ಕೊಡ್ಬೋದು. Student name in the form of that is also the character or a variable character. So project ID is also a variable character. So this is called the logical schema. It defines all the logical constraints that need to be applied on the data stored. So it defines a table, views or integrity constraints, etc. So that is definition which is called the logical design of a database, so that we can call it as a database schema. Then, the database architecture. What is a database architecture? Database architecture is a representation of a DBMS design. It helps to design and develop, implement and maintaining the database management system. In this, the database management system architecture allows the dividing the database system into an individual components that can be independently or in it modifications or any changed or replaced or altered or anything that is in the independently. It is also helps us to understand the components of the databases so that we can call it as a database architecture. On the other hand, the representation of the database management system designing, we can call it as the database architecture. There are the different types of architecture which are present in this the DBMS. So there are mainly three types of DBMS architecture. One is called the one tier architecture. We can also call it as the single tier architecture. One more it is called two tier architecture, and one more it is called three tier architecture. One tier architecture. One tier architecture in database management system. So this is very simple architecture of a DBMS in which the clients, server and databases all residing on the same machine. So which means that so client ಆಗಿರ್ಬೋದು, ಸರ್ವರ್ ಮಷಿನ್ ಆಗಿರ್ಬೋದು ಅಥವಾ ಡಾಟಾಬೇಸ್ ಬೇರೆ ಯಾವುದೇ ಕಾಂಪೊನೆಂಟ್ಸ್ ಆಗಿರ್ಬೋದು, ಎಲ್ಲಾನು ಕೂಡ ಒಂದೇ ಮೆಷಿನ್ ಅಲ್ಲಿ ಡಿಸೈನ್ ಮಾಡಿದ್ರೆ ದ ಟೈಪ್ ಆಫ್ ಆರ್ಕಿಟೆಕ್ಚರ್ ವಿ ಕ್ಯಾನ್ ಕಾಲ್ ಇಟ್ ಆಸ್ single tier architecture. So one example, one simple one tier architecture example is would be an anytime you install a database in your system and access it to a practice in the form of the SQL query. But such architecture is rarely used in the production system. So that is the example for the one tier architecture. So one tier architecture example ಏನಂದ್ರೆ ನಮ್ಮ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ನಾವು ಒರಾಕಲ್ ಅಥವಾ SQL ನಾವು ಇನ್ಸ್ಟಾಲ್ ಮಾಡ್ಕೋತೀವಿ. ಸೊ SQL ಅಲ್ಲಿ ಸೊ ಕ್ಲೈಂಟ್ ಮೆಷಿನ್ ಅದೇ, ಸರ್ವರ್ ಮೆಷಿನ್ ಅದೇ, ಡಾಟಾಬೇಸ್ ಸಾಫ್ಟ್ವೇರ್ ಕೂಡ ಅದರಲ್ಲೇ ಇನ್ಸ್ಟಾಲ್ ಮಾಡ್ಕೊಂಡಿರ್ತೀವಿ. ನನಗೆ ಏನ್ ಬೇಕೋ ಅದನ್ನ ಕ್ವೈರೀಸ್ ಫಾರ್ಮ್ಯಾಟ್ ಅಲ್ಲಿ ಅಲ್ಲಿರೋ ಡಾಟಾನ ನಾವು ಆಕ್ಸೆಸ್ ಮಾಡಬಹುದು. ಸೊ ದಟ್ ಈಸ್ ವಿ ಕ್ಯಾನ್ ಕಾಲ್ ಇಟ್ ಆಸ್ ಅ ಒನ್ ಟೈರ್ ಆರ್ಕಿಟೆಕ್ಚರ್. Then the two tier architecture here is that in the DBMS is the DBMS architecture where the presentation layer runs on a client and the data is stored on the server. So that we can call it as second tier. So client, it is called the one tier, and the server, it is called the another tier. The two-tier architecture, it provides the added security to the DBMS, and as it is not exposed to the end users directly, so that it also provides the direct and faster communication. So this diagram which shows that the two-tier client server architecture. So these are all the clients. So pointer ತೋರಿಸ್ತಾ ನೋಡಿ. These are all the clients, and this is a databases that is called the file server. So in this diagram, the two-tier client-server architecture of a database management system. So we can see that the one server, that is a database, one server which is connected to the client 1, the client 2, and also the client 3. So this is an example for the two-tier client-server architecture. So here, the two-tier client-server architecture, the database architecture where the presentation layer that runs on this client side, and the data is stored in this the server side, so that we can call it as client and server architecture. So that is called two-tier client server architecture. Third one is the three-tier client server architecture. So in this type of a DBMS is most popular client server architecture in the DBMS. So in which the development and maintenance of the functional process, logic, data access, data storage, and user interfaces is done independently as on the separate modules. So for example, the three-tier architecture, it consisting of three different layers like presentation layer, or an application layer, or a database server. So next slide here, the diagrammatic representation of the three-tier architecture. The first layer, it is a client. Second layer, it is a server. Third, third it is the databases. So which means that the application layer resides in between the user and also the DBMS. So that application layer residing, it is in between the user, that means a client, and the DBMS. So which is responsible for the communicating between the user request to the DBMS system and the send the response from this the DBMS to the user. The application layer is also a process functional logic constraints, and the rules before passing the data to the user or down to the DBMS. So in simple concept, it is that it has three layers. This is called application layer. And here is that ಈ ಅಪ್ಲಿಕೇಶನ್ ಲೇಯರ್ ಕ್ಲೈಂಟ್ ಮುಖಾಂತರ ನಾವು ಯಾವುದೇ ಡಾಟಾನ ರಿಕ್ವೆಸ್ಟ್ ಅನ್ನ ಈ ಡಾಟಾ ಬೇಸಸ್ಗೆ ಸೆಂಡ್ ಮಾಡ್ತೀವಿ. ಸೊ ಇಲ್ಲಿ ಆದ ತಕ್ಷಣನೇ ನಮ್ಗೇನಾದ್ರೂ ರಿಕ್ವೆಸ್ಟ್ ನ ಸೆಂಡ್ ಮಾಡಿದ್ರೆ ಆ ಕಡೆಯಿಂದ ನನಗೆ ರೆಸ್ಪಾನ್ಸ್ ಬರಬೇಕು. ಸೊ ದಟ್ ಈಸ್ ಥ್ರೂ ದ ಸರ್ವರ್ ನಮಗೆ ಮತ್ತೆ ವಾಪಸ್ ನಮಗೆ ರೆಸ್ಪಾನ್ಸ್ ಕ್ಲೈಂಟ್ ಸೈಡಿಗೆ ರಿಕ್ವೆಸ್ಟ್ ಏನ್ ಕಳ್ಸಿರ್ತೀವಿ ಅದಕ್ಕೆ ರೆಸ್ಪಾನ್ಸ್ ಬರುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ದ ಸಿಂಪಲ್ ಕಾನ್ಸೆಪ್ಟ್. ವಿ ಕ್ಯಾನ್ ಕಾಲ್ ಇಟ್ ಆಸ್ ತ್ರೀ-ಟೈರ್ ಕ್ಲೈಂಟ್ ಸರ್ವರ್ ಆರ್ಕಿಟೆಕ್ಚರ್. So these are all the goals of three-tier client-server architecture: to separate the user applications and physical database, to support the DBMS characteristics and the program data independence, and supporting the multiple views of a data. Thank you. If you like my videos, please do subscribe to my channel and click on the bell icon for the notification of new videos. Thank you so much.